Hi everyone, in this video we are going to see how to find the equation of the director circle for a given circle. Let's suppose we have a circle like this whose center is located at negative g comma negative f and its equation has been given as x squared plus y squared plus 2gx plus 2fy plus c equals 0. So the radius for this circle would be square root of g squared plus f squared minus c. Now we are going to see how to find the equation of the director circle for this given circle. So first we have to understand what is the definition of a director circle. A director circle is the locus of an external point from which if we draw two tangents to the given circle, the tangents should make 90-degree angle. That means the tangents should be perpendicular to each other. And the locus of such a point is called the director circle. So let's see how that looks. Let's suppose we have an external point, the red dot there. I have named it as point A. And I have assumed the coordinates to be x sub 1 comma y sub 1, and from this point if we draw tangents to the given circle and if the tangents make 90-degree angle, if the tangents are perpendicular to each other, then the locus of this point would be the director circle for the given circle. This is just one particular location that I have chosen, and this point could be anywhere around the given circle. So let's take a few other locations for such a point. The point could be somewhere there on the top left corner. I have chosen one more location there, and let me draw the tangents from that point. And if those tangents are perpendicular to each other, then that point is also part of the director circle. It is located on the director circle. So let's take another location. So I have chosen another location on the bottom left hand side, and from there again if we draw the tangents and if they are perpendicular to each other, then that point also will be located on the director circle. So as you can imagine, we have infinite number of possible locations for this point from which if we draw tangents to the given circle, they could become perpendicular and the locus of this point will form the director circle. So how is the director circle going to look like? Well, for this given circle, the director circle could look something like this. As you can see that you pick any point on this director circle, and from there if you draw tangents to the given circle, the tangents will be perpendicular to each other. So I hope the definition is clear. Now let's see how to derive the equation of the director circle. Here I am going to do a couple more constructions. I joined C with E, and next I am going to join C with D. Now if you look at this quadrilateral ADCE, that quadrilateral is actually a square. Now why is it so? Well, first of all, the angle DAE, that is 90-degree by definition for the director circle. And then we also know that the radius and the tangent at a point, they are perpendicular to each other. That means the angle ADC will be 90-degree. Similarly, angle AEC will also be 90-degree. That means the remaining angle, which is angle DCE, that will also be 90-degree. So as you can see that all of the angles are 90-degree angles. Now that makes it a rectangle. Now we are going to prove that this is actually a square. Now how can we prove that? Well, since this is a rectangle, and if you think about the length of CD and CE, each of them will be equal to the radius of the given circle. And because it is a rectangle and CE is equal to R, so AD will also be equal to R. And similarly, because CD is equal to R, so AE will also be equal to R. Now you can clearly see that all four sides are of equal length, which is equal to the radius of the given circle. So this is actually a square. So the quadrilateral ADCE, that is nothing but a square. Now I am going to join C with A. And then if you look at the triangle CEA, that is actually a right triangle because the angle CEA is 90-degree. So that is a right triangle, and then we can use the Pythagoras theorem and we can say that CA squared is equal to CE squared plus EA squared, because we are interested about the length of CA, which is actually the radius of the director circle, and that's what we are trying to calculate. So CA squared is equal to CE squared plus EA squared. Now what is CE? Well, CE is equal to R, which is the radius of the given circle. And what is EA? Well, EA is also equal to R, which is the radius of the given circle. So we can write it as R squared plus R squared, and that is equal to 2 times R squared. So CA squared is equal to 2 times R squared, and from here we can say that CA is equal to square root of 2 times R. R is the radius of the given circle. It's not the radius of the director circle. So which one is the radius of the director circle? Well, it's actually CA, which is the radius of the director circle. So the length of CA represents the radius of the director circle. Because as you can see, I have brought up the director circle again. CA is actually representing the radius of the director circle. By the way, the given circle and the director circle, they are actually concentric circles. They have the same center, but their radius would be different, and looks like the radius of the director circle is square root of 2 times the radius of the given circle. So it is about 41% larger than the radius of the given circle, because square root of 2 is 1.414, so roughly it's about 41% larger than the given circle. So we have been able to find out the length of the radius of the director circle, and then we can easily create the equation of the director circle, because we already know the center, which is same as the center of the given circle, and we have been able to figure out the length of the radius. So we know the location of the center, we know the radius now, so we should be able to easily find out the equation of the director circle. Now using the distance formula, can we say that x sub 1 minus negative g whole squared plus y sub 1 minus negative f whole squared is equal to square root of 2 times r whole squared, and that is actually 2 times r squared. And from there we can say that x sub 1 plus g whole squared plus y sub 1 plus f whole squared is equal to 2 times r squared. And if we expand the left hand side, we can write it like this, and from there we can write it like this. And then finally we can rearrange the terms and we can write it like this. In place of r squared, I have used g squared plus f squared minus c, and from there we can write it like this. Now if you look at this equation, this also looks like the equation of a circle whose center is located at negative g comma negative f, and the constant term is represented by 2c minus g squared minus f squared. By the way, the c, g and f, they actually come from the equation of the given circle. So you will be provided with the equation of a circle, and based on that you have to find out the equation of the director circle. So here we are trying to find the equation of the director circle based on the information provided in the equation of the given circle. So here I have made a few notes here on the left hand side. I say this is nothing but equation of a circle. Its center is located at negative g comma negative f, and the radius is square root of 2 times r. So if we replace the x sub 1 by x and y sub 1 by y to bring it to a general form, then we can write the equation of the director circle like this. So essentially I am converting this one equation into a general form which looks like this, which is on the bottom left hand side, and that is the general form of the equation of the director circle for a given circle. So we can actually use either of the two forms. I have highlighted both of them. I prefer to remember the left hand side one. That's easy to remember because it has the same center. So it will be x plus g whole squared plus y plus f whole squared. The only difference would be on the radius, because the radius of the director circle is square root of 2 times the radius of the original circle. So we can say that it would be square root of 2 times r whole squared, that is 2 times r squared. So I think it's very easy to remember the equation which is on the left hand side. That is the equation of the director circle. And also another important point to remember is that the radius of the director circle is square root of 2 times the radius of the original circle. That is very important. We need to remember that. And then based on that, we can easily remember the equation of the director circle which is on the left hand side there. Next, we are going to take an example. Let's suppose we have an example like this that says find the equation of the director circle of a circle whose equation is x squared plus y squared plus 6x minus 4y plus 4 equals 0. So we have been provided with the equation of a circle, and we have been asked to find the equation of the director circle for this given circle. So let's try to solve it. The given equation is like this, and if we compare that with the general form of the equation of a circle, then we can say that 2gx is equal to 6x, and from there we can say that g is equal to 3, and similarly 2fy is equal to negative 4y, and from there we can say that f is equal to negative 2. And let's calculate the radius, that is equal to square root of g squared plus f squared minus c, and let's plug in the values. The radius turns out to be 3 units. So let me make a note of that on the right hand side. So we have found all the necessary information for us to be able to find the equation of the director circle. We already have the standard equation of the director circle, which is x plus g whole squared plus y plus f whole squared is equal to 2 times r squared. So let's just plug in the values in that form. If we plug in the values in that form, then the equation going to look like this: x plus 3 whole squared plus y minus 2 whole squared is equal to 2 times 3 squared. And now let's expand everything. The left hand side will be like this, and then the right hand side will be 2 times 9, that is 18. And if we bring everything to the left hand side, then our equation is going to look like this. And this is the equation of the director circle for the given circle. And that is our answer. I hope everything made sense. Thank you for watching. See you in the next video.